Well, good morning, good evening, depending where you are watching from. My name's Zach. Welcome back here to the Launchpad. Here at the Launchpad, we cover everything space, space flight, space engineering, and the future of space. And we are so excited to welcome you here this morning for our live coverage of the Blushift Aerospace test flight of Stardust 1.0. Uh, we're keeping an eye on it. They've had a couple delays here this morning, which is why we're a little bit later coming on here. They're currently targeting an attempt in the next about 45 minutes to an hour and 45. They're currently waiting for some weather to clear for them with cloud cover. So we're going to hang out here. It looks like we are getting our first live views of the rocket. So I'm going to get that pulled up here for us in a moment. And then we'll talk through a little bit more about Stardust 1.0 and what Blushift Aerospace's goal and aims are, because it's a really interesting concept. Currently, they are in a race with a organization in Nova Scotia to create a northern North America small launch facility. So really exciting to see them taking their first steps here after many, many years of research and development and engine testing.
If you're just joining us, this is a Blushift
Just hearing what they're saying here.
fully integrated rocket on the launch pad.
I will pull this up here so you can see it.
And we've got some news about the weather.
It looks like the forecast is not improving at this point. So the odds of launching by 1 p.m. have just gone down.
Okay.
Just holding tight for weather.
Like anything with a rocket launch, it seems get stuck with the weather. But we'll hang out here until they decide whether they're going to go or not. I'm going to keep this on here so I can listen in, and I'll bring back up their feed should they be bringing anything up here. But while we wait to hear kind of what's going on with Blushift and Stardust 1.0, a little bit of information about the rocket and Blushift Aerospace. So today they're launching their Stardust Gen 1 rocket. You can find out more about their organization at blueshiftaerospace.com. That's where I'm getting all my information.
All right, and so a couple of sources indicate very decent chance of launch at 1 p.m., but there doesn't seem to be general agreement across sources.
Okay. They're debating in the launch room on whether they want to go for a launch attempt at 1 o'clock now, which would be giving us about an hour and 45 minutes. But we will see what they say. I'm going to talk through a little bit about them, and then we'll jump back in and see what they're saying. I've got their Twitter pulled up, which really awesome. They've been doing a really good job at trying to keep people informed on their Twitter. Obviously, first test flight, so all of this is new to them. So really, really interesting. The biggest thing about Blushift Aerospace is they are designing and manufacturing a bio-derived fuel-based rocket. So they're trying to develop a unique line of rockets. So currently they're trying to design 4 of these bio-derived fuels to launch tiny satellites into space from a northern launch facility, and then it could transition into other launch facilities as well. So the biggest thing is they're looking to make rockets like no one has before by integrating a number of different technologies for the first time into one physical motor, which is why they've had many, many years of research and development and testing of their engines, and this is their first flight for it. Not only does their approach increase performance by using sustainably farmed fuel, but the fuel also migrates the detrimental impacts on the environment because versus like a traditional liquid or rocket fuel, because it's sustainably farmed, it's developed for it. You're not having to mine things and stuff like that. So they really are hoping. This is a really interesting shot, is seeing the person actually next to the rocket here for it. These are not big rockets. As we said, this is a small payload. Today's launch, I believe they're attempting up to about 4,000 feet. I've heard they were cleared to 5,200 for it. And there are 3 small payloads that they are having on top of that rocket currently. And they will be doing, looks like he's adjusting some of the strong back, maybe? It's interesting to see, when you're watching a Falcon 9 or Starship, normally don't see people this close to the rocket. When it's originally was supposed to have already launched, landed, and we'd be gone a couple hours ago for it. So this is a cool thing to see here for it. So you might ask, well, where did Blushift Aerospace get their money? Who's the rich person in the world backing them? And there really isn't. Blushift has made their progress of their small satellite launch vehicle since 2014 is when they started. They invested over 500,000 US dollars in their own resources of their team for it. And they have been awarded grants from NASA and the Maine Technology Institute for the rest of the development. And I was watching an interview with their CEO, and he was saying one of the really nice things about having these grants is they keep you working. If it's only your own money, we can take a week, or let's not rush. When you're on a grant for NASA and universities and stuff, they keep you going, and that's why it's really pushed you even through those harder points to continue to maintain their work. They've also launched a Patreon, so people like you and me can help support and be part of launching this. You get some gear and logos and stuff there, so you can check that out. The other way is you can also book a flight. It's something you can do right now on their website. You pull it up. Obviously, today's one is busy, but they've got a few more lined up actually as well. So first flight of Stardust 1.0 scheduled for today. We'll see if that's going to happen or not. We've got another one lined up for July 8th, then October 8th, then May 8th of 2022, and they've got ones planned all the way to 2025. What's exciting is the next first launch of a new type of rocket for them will be Stardust 2.0, and that is targeting for October 8th, 2021. And then not long after, October 8th, 1 year later, they're looking at targeting the launch of their Starless Rogue first flight. So they've got a lot of launches coming up that they are excited for. And then their Red Dwarf, they're targeting for 2024. So, we've got a few years here that we're looking at them testing their four types of vehicles. But it's exciting to see them start. So they do have 4 vehicle types. I'll see if I can get this pulled up on here. Just give me a second here. We will pull this here. And we want to do this one. There we go. A little bit small, but we'll swap these out here. There we go. Make this one just a tad bigger. There we go. So these are the 4 rockets they are going for. So today they're going to be going and attempting the launch of Stardust Gen 1. Then by October, their goal is to be launching Stardust Gen 2, going into Starless Rogue about a year and a half later, and then Red Dwarf by 2024. So you can obviously see, these are small rockets that they're aiming to go for. But that's exciting. It would be really neat to have something in the northern part of North America for rocket launches and stuff there. So yeah, we'll pull this back here. There we go. And we'll dive a little bit deeper into them here in just a moment. But if this is your first time here at the launch pad, hello, my name's Zach. Here at the launch pad, we cover everything space flight, space engineering, and the future of space, which is why we're covering today. And I'm hosting here from my home in Canada, but we cover everything space in Canada, US, Europe, Russia, Australia. We've got Rocket Lab, I think, that's coming up late tonight. So we're hoping to give coverage for that as well. So make sure you hit like and subscribe. It really does help out the channel and let YouTube know that people are interested in this, because we really want to be here helping bring live coverage, explain things, and just let you know more. If you're new to our channel, we do a new weekly news every Monday. And you can, come check that out, see what's coming up, what happened in the last week, and what's coming up in the next week there. I'm just going to check Twitter here for a second, see what's going on with their flight today. And Yeah, if you are here, feel free to help share the broadcast out. Huge help for people knowing that we are live and we're talking here, as we'd really love to have all of you join us. If you have a question, we do have the chat here, and so feel free to let us know what's going on. Let's check this here. There we go. Yeah. So a little bit deeper into what today's rocket is and the test of it. So it's going to be a basic test vehicle, requiring tests for the engines mainly to see what about the vibrations, the acceleration. They've done many static fires in the testing of the engine. They've done 2 static fires for the actual rocket itself within the last couple of weeks. And then so if they can make their attempt today, we're going to be seeing that launch up to about 4,000. They're cleared up to 4,200, cleared up to 5,200, just to see how the vehicle holds, what vibrations there are, the acceleration, really everything you can't test locked to a structure. They really do need that flight. And then they're going to test their payload recovery. So they're going to attempt to recover the rocket itself, as well as the 3 payloads that are on board. They said for the future, this model of rocket is really great for student and budget payloads that are for that lower altitude. The max altitude this rocket can go that they think is 4,000 feet. So no microgravity. It gets up to a maximum acceleration of 2G. There's no spin to it. And for the payload diameter, you're at 14 inches. So you're just a bit bigger than a standard sheet of paper. And the maximum payload is 8 kilograms. So small turkey. And the vehicle height is only 20 feet. And we saw that when that person was next there. Looked a little bit taller just with the angle. But yeah, there's 1 stage for the vehicle. And this is their Stardust Generation 1. Now, they do hope to, following this, later this year, test Stardust Generation 2, which is an upgraded test bed from today's version, which does a higher velocity, which means it can get through more atmosphere and do a longer flight. So Stardust 2, which we're hoping to see later in the year, can get up to 40,000 feet. Still no time in microgravity, but it does go up to 5 Gs of acceleration, and the payload diameter is quite a bit bigger at 24 inches. It can carry a 30-kilogram max payload. Vehicle still only 21 feet, so not much bigger, and it's still a 1-stage vehicle. And then they go on and on as they grow. Ultimately, they want to get to their they have their 2 rockets that they want to get to as their operational. So they want their Starless Rogue, which is their state-of-the-art ride to suborbital space, providing some of the longest zero-G time at 6 minutes into the launch, but it's still a low launch acceleration of only 5G. And then they want to get to their Red Dwarf option as well, which is a low Earth orbit launch vehicle that they can tailor to whoever their payload is. But it is still 30 kilograms or less. So these aren't huge rockets we're talking about for their future, but they're really going to be providing for small organizations, schools, things like that, that are getting there. And if we look at satellites, they're getting smaller and smaller for what is needed to get them to orbit and stuff there. So I'm going to take a listen in here.
So we're going to reach 5,200 feet above sea level. And sounding rockets can go anywhere from tens of thousands of feet to hundreds of miles, depending on the mission.
Let you listen in
So we
here.
won't be flying a kind of a normal profile for a sounding rocket, but it is a suborbital trajectory. Now, as we scale up, we do plan to develop Starless Rogue, a 2-stage suborbital vehicle that can lift 30 kilograms to 150 miles. and also the red dwarf 3-stage to low Earth orbit. GJ840 asks, why use a hybrid instead of a liquid? Wouldn't it be much easier to scale and be more efficient in general? Excellent question. Well, I shouldn't pretend my area of expertise is in liquid-propelled rockets here. But I would argue that we're shifting the efficiency around to production and also only having a single set of plumbing in there for the oxidizer. There's fewer moving parts, it saves you weight, fewer things that can fail. So there's a lot of advantages. We don't have quite as fine of a control on throttle ability with a hybrid, but still enough that if you were to cluster the engines in a stage, you'd be able to steer the rocket through differential throttling.
I'll come back in here. Seems like they're just asking some questions in their chat of people that are waiting. And we'll just mute them there, and I'm listening in here. So you might hear them through my mic a little bit as well. But yeah, we're just waiting to see what they're going to do, whether they're going to make an attempt or not. I do have their Twitter pulled up. They haven't said anything yet. They're still targeting between 12 and 1 p.m. Eastern for their launch attempt due to cloud cover. So that's the one thing they're hoping that cloud will cover. And as you can see from that live video, it's pretty socked in there for it. So if you do have any questions, let us know in the chat. I do have that pulled up here. And if I don't have an answer, we'll go Googling and we'll find the answer of it. I am not with Blushift Aerospace in any way. I'm the host here at the launch pad. So thank you for joining us. And we're here for the coverage of the first attempt of the launch for Blushift Aerospace ever, and their Stardust 1.0 rocket. They're launching from Limestone, Maine, USA, from the Loring Commerce Center. And we're excited that they're doing this live feed for everyone to be able to tune in and see what's going on. And we'll see if they're going to go for an attempt today. Let's just see what's coming up.
East coastal launch site for launching due south of original flight to October. Now, for how the idea is progressing, it was considered as a bill last session, and so the beat will be voted unanimously by partisan support not to pass on 2022.
Apologies. A Leadership Council. Now, the bill never made it all the way to the floor, as the state government kind of pivoted to focus on coronavirus.
We're just listening into what they're saying on their Blushift coverage here.
So I don't have the most current information on where we go from here in terms of state politics.
So I
but
think
we did recently receive a sizable grant from the EDA.
So they're talking a bit on just the funding that they have, on how they're funding Blushift Aerospace and these tests. Obviously, developing a new rocket engine and testing it is not a cheap thing. You know, we're hoping that they have a successful flight and recovery today and that they don't have a rud on the pad or in the air, but it's a test flight, so we never know what's going to happen here. I mean, if we look back at SpaceX, look how many times it took them to launch and land successfully. Now, landing more similarly to the Rocket Lab Electron via parachute, but they're not going to be attempting to catch it with a helicopter, or at least not at this time, and they haven't shared that that's in the future, but we'll see. Rocket Lab has shown it works, so they might be able to adapt that in the future generations, maybe with their actual orbital version or not. I'm just taking a look back at what they've done. They've had a very busy beginning of the year in December. For it. On the 24th, they actually released that they conducted their test launch of the prototype of the engine that's on today's Stardust rocket. And then a week later, they did another test of it. And you can see those tests on their YouTube channel. We'll pull them up here probably a little bit later for it. And yeah, they were getting ready. So their local news was starting to pick up on it. And then just a few days ago on January 12th, they announced that they were going to go for an attempt for today's flight for it. Again, you're watching live coverage of the Blushift Aerospace Stardust 1.0 test flight launch. Flight. They're going to be going up to about 4,000 feet today and attempting to recover the rocket, as well as 3 payloads that are on board in that black nose cone there. All will parachute back to Earth for today's flight. We are just waiting to hear from them whether they're going to go for their attempt or not. They've pushed it back several times this morning due to cloud cover. Currently, they are targeting between 12 and 1 p.m. Sounds like they were targeting kind of the end of that, closer to the 1 p.m. mark, but it sounded like there's still some debating on whether they want to go or wait for a clearer hour, or maybe even waiting a day and going for a clear day. Since they're only going up to 4,000 feet, not a huge deal. Like, obviously, there's still regulations and stuff, but not a huge deal in, having to have a clear window and deployment of payload and things like that. So, waiting to see what's going on here. Excuse me. Originally launch was scheduled this morning for 7 a.m. They were planning to go live, I believe, for an 8 or 9 a.m. launch. So we're a few hours behind what they were originally planning. But better safe than sorry. I mean, I think we've seen that with Falcon 9 and Starship and many other rockets. Take your time, do it slow, better safe than sorry. So I'm going to pull up their feed here just for a little bit. We'll listen in. I'll pop back in if we hear anything else, or every once in a while just to say hello. And we'll keep talking a little bit more about Blushift Aerospace and their Stardust 1.0 rocket. So I'll be back in a few moments. Thanks for joining us here at the Launchpad. My name's Zach. I'll be right back.
see a couple of questions about cameras on board the rocket. Happy to say we've got 5 cameras. They're not on right now. The payload bay is powered down to save precious battery power. But we should have some really good footage for you guys through the flight. Mo Harris asks a shout out to MSSM students. Myself, I'm a proud graduate of the Maine School of Science and Math, just a couple minutes from our launch site here. So hey guys, hope you're having a good break. Hope you're keeping safe and healthy. And I'm sure that nobody has to tell you this, but study hard. Mindvent asks, how high are we going today? And the plan is to reach 5,200 feet above sea level. The maximum altitude was previously 4,000 feet. That was more of a permitting issue than a mechanical issue with the vehicle. We got cleared to the higher altitude for a couple of different reasons, but chief among them was just making sure that we burned through all the fuel during the main engine firing. There is a little bit of static on the feed. Sorry about that. We're piping sound through an FM transmitter for specially invited guests or tuned in their vehicles from a safe distance on the south end of the runway. We've mitigated the buzz as much as possible. There's tons of coils and ferrite beads here in the studio. But at the end of the day, we've got an FM transmission and a live stream coming off of the same source. There's going to be just a little bit of a buzz. Now, depending on how this launch goes, and depending on how our next round of capital goes, we may be able to resolve that issue for our next launch. Graham Edwards asks if we aspire to orbit for 2021. Sure, that would be amazing. I think we'll be pretty proud of ourselves if we make orbit by 2024. This year, assuming that the mission here goes nominal for Stardust 1.0, the focus moves to Stardust 2.0, which will reach higher altitudes, go through a more intensive permitting process, and lay the groundwork for the 2-stage suborbital rocket Starless Rogue, which will basically just use a Stardust 2.0 as the upper stage. My God, is that NASA spaceflight in the chat? That's amazing. Hi, guys. We're big fans. Probably no surprise. If you're just joining us, this is a Blushift Aerospace live stream and FM transmission of the launch of Stardust 1.0, Maine's first commercial launch and the world's first commercial launch of a rocket powered by bio-derived fuel. We've got 3 customer payloads aboard, and we're ready to demonstrate our proprietary bio-derived fuel in flight and show also the growing demand for these suborbital flights. We've got a couple updates about weather and a new timeline. It looks like our best chance for good weather is going to be between 2 and 3 p.m. I'll say here it's a 50-50 shot. We don't really know what it's going to look like at that point. So with that in mind, the plan is to begin the oxidizer tank fill at about 1 p.m. Call the FAA to give our 1-hour notice. And weather permitting, we'll launch between 2 and 3 p.m. Now the outlook is, given what the weather looks like for the rest of the day, if we have to abort the launch, it's probably a scrub, and we would probably be looking at a new launch date early next week. For folks in other time zones, 2 p.m. will be just over 2 hours from now. Someone in the chat asked our FM frequency. It's 92.9 FM. There really isn't not much distance on that, so unless you're on the south end of the runway, probably live stream is your best bet. So Stardust 1.0 is a single-stage vehicle. It will, however, split into 2 bits. You can see our launch sponsor, Rocket Insights. You can see their logo on the lower half of the vehicle. There's a line right above it. And that horizontal line is where at apogee Stardust will split into 2 sections connected by a tether. A drogue chute will come out, and then main chute will deploy roughly 1,000 feet above the ground. Someone asked, Hyder, does the company have a Patreon? Why, yes we do. You can look up Blushift Aerospace and Patreon, and I'll drop the link in just a minute. And I saw somebody asked about our...
How about I turn my mic on? There we go. Hello, everyone. Welcome back. My name's Zach. I'm the host here at the Launchpad, and today we're covering the launch attempt of Blushift Aerospace, launching from Limestone, Maine at the Loring Commerce Center. They're on the runway there. They have been having some weather delays due to cloud cover. Currently, it's sounding like they are going to go for an attempt in about 2 hours. We're going to stay live here as long as we've got their live feed from their facility for it, and we'll probably just listen in for a bit. But we want to thank everyone for joining us here. Make sure you hit that subscribe button. We're going to talk a little bit more about Blushift Aerospace, kind of what they're doing, what's their targets and goals, and then we'll listen back in there as they go for an attempt. It sounds like at about 1 o'clock their time, they do want to go for fueling, which is about an hour from now, and then they'll let the FAA know that they are doing that fueling in preparation for launch. So things are still progressing. Their team still sounds like they're in good spirits. Sounds like it's about 50-50 chance, but you want to make sure you're doing the right thing, especially on the test flight of the vehicle. So yeah, we're going to dive a little bit deeper in here. I'll leave their feed there so you can see it here. But yeah, Blushift Aerospace has been in work for many, many years, actually. They started in 2014 when they invested $500,000 of their own money. And once they started kind of proving that, they have some ideas and things are working, they've received a number of grants from NASA and the Maine Technology Institute, among others, to help accelerate their research and development. They've also done it from support from people like you and me. They have a Patreon, they have merch, and you can also book a flight. They have their flight schedule up all the way into almost 2025 already, showing their timeline of how they want to test their 4 different vehicles. And yes, you heard that right. They have 4 different vehicles that they're wanting to launch. The first one is the Stardust Gen 1, which is what you see on their pad today. For it, Stardust Generation 1 is the basic test launch vehicle for experiments requiring sub-ejection vibrations and accelerations at launch. That's what they're testing. What are those vibrations like? How does the engine accelerate and the vehicle accelerate with the biofuel engine? They said it's really great for students or budget payloads that want to attempt like parachutes or different things there. They will be attempting to recover today's rocket via parachute as well as the 3 payloads. Originally, they were going for 4,000 feet due to their regulation filings. It does sound like they've been increased up to 5,200 feet today for it. So no time in microgravity. At max acceleration, they are going to reach 2G. There's no spin or rotation for today's launch, and the payload diameter is 14 inches, so just a little bit wider than the length of a sheet of paper. Max payload's an 8-kilogram payload for it, and the rocket's 20 feet tall. We did see earlier they had someone go up and adjust some things next and behind the rocket, and you could see a person there. So not a huge rocket for it, but it's a really great first step, proving their engine, proving their science. Going from there, it is a 1-stage engine as well. By October this year, they are hoping to attempt the launch of their 2nd generation, Stardust Gen 2, which is going to be an upgraded version of the one you see today. It's going to have some slightly different fins on the bottom, and it's going to be for experiments that need a higher velocity, a much higher altitude. The Stardust Gen 2 will fly to a height of 40,000 feet, is currently what they are scheduled for. Again, no spin, but will receive 5G at max acceleration. Payload quite a bit bigger there at 24 inches, and the weight goes up substantially, up to 30 kilograms as well. And the vehicle height's 21 feet, so only about a foot higher than the one you see here today. So wider, not taller, but can go quite a bit higher. Again, a 1-stage rocket. Then about a year later, once they have a successful Stardust Gen 2, is when things get really exciting for Blushift, and that's when they're going to be starting to launch and test their 2 main rockets, which are going to be their Starless Rogue and their Red Dwarf. So the Starless Rogue is a state-of-the-art ride to suborbital space, providing some of the longest 0G time at 6 minutes into launch, and it has a low launch acceleration of under 5G, and no spin stabilizes make sure that the Starless Rogue is an ideal candidate for fragile payload loads that need exposure to space. With a reduced payload, Starless Rogue can be used for hypersonic testing, reaching velocities up to Mach 6 and 7. So they do have quite a bit of flexibility with the Starless Rogue. And then about a year later, I believe that one they're wanting to test in 2022, 2023. 2024 end of the year, they want to test their Red Dwarf, which is their low Earth orbit launch vehicle, which can be tailor-made to fit the different nanosatellites from their community and the community of ride shares. It's designed only to fly 30 kilograms, so not a ton more than the Stardust Gen 2 for it, but it's dedicated for 1 or 2 nanosatellites without receiving a high G. So it's still a low launch acceleration, again, for fragile payloads. So they're really opening up the opportunity for small payloads, for smaller organizations to have an option. They're currently in a race with another organization in Nova Scotia, doing a similar idea of having a launch facility in northern North America on the East Coast. There in Maine, there's another one in Nova Scotia that I believe they're also going to be having some testing early into this year for it. If you're wondering where all this information is coming from, it's coming from BluShiftAerospace.com. They've actually got a really great website explaining more about them, their hopes and their missions, where you can get their merch, see their team, and they actually have some pretty good merch. So we might have to see if we can get some here. But they actually have their book of flight, and I think that's where it's really interesting. is they have laid out their plans all the way to May 8th, 2025 of where they see Blushift Aerospace going for it. So their first test flight of any rocket is today. They want to see October 8th this year. They want to test their 2.0 version of Stardust after one more Stardust 1.0 in the summer. They want to do 2 Stardust 2.0 launches. And then by October 2022, they want to be doing their first flight of their Starless Rogue, which is one of the 2 main rockets. And then exactly a year to date later, they want to launch their Starless Rogue, and then Red Dwarf is 2 years later. So they've got a number of launches there, and you can view their events and see what's going on. Currently not selling space on a number of them, just as they want to see how today's flight goes and stuff there. But definitely something to keep an eye out. It's really nice having a scheduled timeline out there for a while. So while we are waiting for this weather to clear, we're going to just listen into their live feed and see what's going on. If you have questions, let us know in the chat. Again, my name is Zach. Welcome to the Launchpad. Make sure to hit that subscribe button, and we will be back here in a little bit. If you have questions, again, let us know in the chat, and I'll be back to answer them. So this is live coverage of the Blushift Aerospace Stardust 1.0 test flight, live here on the Launchpad channel. Enjoy.
Scrap Over Engineering asks, what was the name of the Amsterdam-based company which sends the stroopwafels? I believe it's Dept. Delta Echo Papa Tango. Dept. A couple people from Rocket Insights came up to watch the launch, and some of them are even helping direct traffic, which was just amazing. Really, really like just fun people. There's some questions also in chat about the reusability of the vehicle. Stardust 1.0, of course assuming nominal flight parameters, is fully reusable, save for this tiny little kind of tined collar of metal down at the base of the vehicle. It almost looks like the back of a jet engine, but it's not. Its purpose is twofold. First of all, it's a little bit of a crumple zone during the litho braking maneuver. The Marvel or modular adaptable rocket engine for vehicle launch is going to split off from the payload bay, and they'll descend tethered together, and then once the main chute comes out, the engine will touch down first. This means that the payload bay will have several seconds of additional deceleration for a softer touchdown. But when that Marvel touches down, it just seemed like a good idea to have something to absorb shock. So those tins will probably crumple a little bit, and we'll switch them out for the next launch. Now the other purpose of those tines is to help keep brush away from the engine nozzle in case it still is warm. That engine should be very thoroughly cooled by the CO2 flush after main engine cutoff. I say main, of course there's only one engine. After engine cutoff. And also the air 5,000 feet above Limestone, Maine, I'm sure will do a terrific job of cooling the engine. But in the event that it touches down hot, those tines will also, crumpled or not, just help keep stuff clear of that nozzle. Anyway, that one component isn't reusable, but everything else, if the flight goes to plan, will be. Now, down the road, as our rockets carry heavier payloads and they go higher and farther, reusability is very much on the drawing board. Can't go into any specifics here. But if you want to do new space at this point, you pretty much have to be thinking about reusability, and that's a good thing. If you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0, our prototype sounding rocket. This marks the first commercial launch of a rocket here in Maine and the first commercial launch of a rocket powered by a bio-derived solid fuel in the world. Currently, we're holding for weather. We'll be flying to 5,200 feet today and need less than 50% cloud cover at that height. We were previously cleared to 4,000 feet. Got it bumped up to 5,000, but it sounds like there's pretty steady clouds everywhere above 2 for now. There's a good chance that the weather will clear up between 2 and 3 p.m. If that doesn't work, then the chances are we're going to scrub for weather and reschedule to next Tuesday or next Wednesday. All right, in the chat on our live stream, I see some folks questioning why one would launch from Maine, specifically referencing our, well, I guess what you could describe as excessive latitude. Now, it's true when you go to orbit, the closer you get to the equator, you get kind of a bump from the Earth's rotational speed. And it'll shave about 1,000 miles an hour of delta V off of what your rocket needs to do to achieve orbital speeds for an equatorial or low inclination orbit, proceeding from west to east. If you launch from higher up, then you need to spend more fuel, essentially going sideways, until you achieve such a great sideways velocity that the ground curves away at the same rate that gravity pulls you down. Thus, you achieve orbit. So, why then launch from a high latitude? Well, for a high inclination orbit, such as a polar orbit, where you go over the South Pole, either perfectly or very nearly, and about 45 minutes later, because low Earth orbit, right? 45 minutes later, you're halfway around the world at the North Pole, another 45 minutes back at the South Pole, while the Earth is rotating under the satellite. It's a terrific orbit for communications, for Earth imaging. And so for an orbit like that, you need to cancel out the Earth's rotation. So if you're trying to reach a polar or near polar orbit, launching from the highest latitude possible, either as far south or as far north as is reasonable, gives you fuel savings. Basically the same kind of fuel savings you would get if you could launch comparably close to the equator for a polar orbit at the same altitude. So with Maine's high latitude and south-facing coastline, in down east Maine, you've got about 1,800 miles of ocean overflight. So it's a safe and efficient way to launch to polar and sun-synchronous orbits, while still contiguously connected to the United States eastern seaboard. And with some really terrific accommodations. We are vacation land. We're also going to be rocket land, though. The future of space will be made in Maine. Gaming Cube 47 asks, when are we planning to reach space? On purpose, I assume. In all seriousness, in about 2 years, we, if all goes to plan, we'll be launching Starless Rogue. That's our 2-stage suborbital. And that can get up to 150 miles, so well above the Kármán line. And so, first flight of Starless Rogue, that'll be when we reach space. Jan Piotrowicz asks, how big is the team that made this rocket? Between employees and interns and contractors, at any given time there was probably about 10 people, give or take, working on this project over the past 6 years. Cost of Stardust, the launch pad, the R&D that went into both. If you factor in donated person hours there, close to $1 million getting to this point. All right. We've got a more specific number on the cost of Stardust 1.0 here for you. Factoring out more general company expenses, the rocket and the tower together is about $260,000 with labor and materials and other supplies. I got a couple of requests to cancel the background music. That may make the buzz a little more prominent, but if a lot of people feel that way, we can definitely pull down the music. All right. The people have spoken, the music shall stay. Someone asked how many engines Starless Rogue is going to have, the two-stage suborbital. It's a cluster of 4 engines on the first stage, and then a single engine on the second stage. Well, if you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0. This will mark Maine's first ever commercial rocket launch and the first commercial rocket launch of powered by a bio-derived fuel ever. Currently, the rocket is doing all right. All systems go. The weather is a bit of an issue. Due to cloud cover, we're holding from a launch that was originally scheduled pretty early this morning. We're now looking at 2 to 3 p.m. as our window for weather. Getting a lot of comments in chat about the fuel. Feel free to keep discussing it, of course, but I just can't really comment on it. Happy to answer other questions, though. I can talk a little bit about hybrid rockets. Well, it's funny, someone asked if I used to be a radio DJ. Ryan, the answer is yes. In fact, that's how I met the CEO. I had a radio talk show about space science and exploration in Portland, Maine. And I found out about this rocket company up in Brunswick on Facebook. And And so we had a little back and forth, and we got this EO in to do an interview. We had so much fun that we did 2 interviews. And before I knew it, I was interviewing for Blushift. I had to step away from the radio show to focus on Blushift, but it continues. All of the other panelists are still there on WMPG as Scientifically Speaking. Right. We've got a little bit of a treat for you. Blushift founder and CEO Sasha Derry is going to join us in just a couple of minutes. Quick Q&A. Michelle Griffin asks, wondering if the fuel being used could be efficient for launches on the Moon, Mars, etc. I can say that that is on the drawing board. Right now we're experiencing temperatures comparable to those at the Martian equator, although the pressures, well, there's more here. Alistair Mitchell asks, what materials are you using for structures? Well, the skin of the rocket is a composite, and the internals are a mix of aluminum and steel. Steel mainly for affordability. It's very rare to see that on a rocket, and certainly, our future rockets will have more aluminum, less steel. If you're just joining us, this is a Blushift Aerospace live stream of the launch of Stardust 1.0, Maine's first commercial launch and the first launch commercially of a rocket powered by bio-derived fuel. We're holding now for weather, expecting clear skies somewhere between 2 and 3 p.m., or at least clear enough to launch. All systems are go on the vehicle. And as we wait, I am joined here by Sasha Derry, founder and CEO of Blushift Aerospace. Sasha, hello. Thank you so much for taking time to join us here.
Good afternoon. Thank you, Seth, and everybody who's out here for suffering through this cold.
Well, someone asked if I had experience as a radio DJ. I told them how we met.
Yeah.
And this is really bringing back some memories.
Full circle.
Yeah. So how's it been for you today? Before Blushift was incorporated, you were already working towards this day. So we're talking over 6.5 years at this point, right?
Yeah, this is 6.5 years of the accumulation of 6.5 years of hard work of many individuals, and hardly just me, but a lot of really talented individuals to get us here. And it could be a historic moment if we can light this candle. We'll be setting possibly 2 new records, being the first commercial vehicle rocket to launch from Maine, and being the first commercial launch in the world using a bio-derived carbon neutral fuel. Now, I know a lot of people are going to guess that it's blueberries and manure or ethanol. It's none of the above, but we can show you it's bio-derived and carbon neutral. But this is incredibly exciting for all of us, and I think there's a lot of anxiety, but we're feeling pretty good right now. Everything technically is in place, and it's just the weather.
Yeah, it really is everything on the line in this, and I'm lucky, because none of the buttons that I touch here are going to make anything explode.
Thank goodness.
Yeah.
Unlike what happened last night. No, sir.
No. But it's just been really amazing to see you guys collaborating and problem solving through the static fire tests and through the past couple of days as we get the rocket up on the tower.
Seth, you and I have been here since Sunday, setting up the network and systems ready, and the rest of the guys came in on Monday and Tuesday. But our engineering team, Luke, Brooke, our interns, Ben, other guys, Mike and Corey and Gerard and others, David Hayrikian, have been so instrumental into getting us to this point. And not everybody could join us here. And there's many people who are part of the Blushift team that some live far away, and they've contributed over the years. But whether it was 6 years ago, 3 years ago, or this week, people have been working early mornings, through the days, and late into the night to push this effort forward for Blushift, in this case also for Maine, but also to demonstrate how a small launch vehicle. Well, how we provide ultimately dedicated small launch vehicle access for tiny payloads.
Yeah, so let's talk about that a little bit. A lot of companies right now they're going volume, right? I mean, SpaceX is launching like a lot more CubeSats ago than we ever planned to. We're doing 30 kilograms.
Yep.
And that's it. So we're not competing with them. We're not even competing with Rocket Lab, really. We're carving out this new niche. Yep. Why are we doing that?
Well, I'd like to say, if you bring it down more terrestrially, it's kind of like SpaceX is the freight trains to space, and there's definitely a market for that, a big market for that. There are bus lines to space like Rocket Lab, Virgin Galactic, and Virgin Orbit, and others. And what I expect us to be, is the Uber to space. We're going to be able to, because of our technology, where we're launching from here in Maine, ultimately off the coastline into polar orbit. But how we're going to be operating this company, I believe that we will be able to launch profitably 1, 2, maybe 3 payloads at once in our payload section. For rockets, they need to collect either very large payloads or dozens of ones to turn a profit. So we think there is a real niche market for us that's currently not tapped by many other companies in the world.
And Blushift is one of the things that makes Blushift so cost competitive is the fuel has a 0 TNT value. There's no cryogenic storage or anything like that, so the handling costs go down as well as the manufacturing costs. And my favorite fact about the fuel is that, well, I don't know if we can call it edible exactly.
No, although I think you could find components of our blend in food products, but yeah, you could eat it. I probably get in trouble for saying this for the billionth time, that I could feed it to my daughters, and the worst thing that would happen is they might get constipated, but I wouldn't do that to them, I swear. But it's a very safe fuel. In fact, I tossed one of our sample fuel, a small subsection of it, a few days ago with some neighbors onto a fire, and everybody stood far away, and it's no more explosive than a piece of wood. Just burns.
That's amazing.
Yeah. Now, another important aspect about why we're able to keep the cost down has to do with the hybrid rocket technology itself. It allows us the throttleability control that a liquid rocket has, but half of the valving and control systems, the tubing and solenoid valves that you might need on a liquid fuel rocket. And that means a lot. That means not only a lot during manufacturing, but of course during the research and development phase, a whole lot less complexity. And because neither our fuel nor our oxidizers are toxic, that means the handling costs are quite a bit less. Launch environmental costs are negligible, except for when we first get our permit costs. And it means that we can feel confident that when we launch off the coast of Maine, that we will not be contaminating fisheries, wildlife, or habitat, or affecting habitat. Something I think that you can't say about many rockets in this world today.
Yeah, so about that, because it's not just a bio-derived fuel, it's also a non-toxic fuel. There's no heavy metals, no rubber, unlike some other companies that are operating vehicles that use a hybrid rocket right now.
Sure. Yeah, exactly. Virgin Galactic, Virgin Orbit. Yeah, I mean, you can carry our rocket down the road without any special DOT rating with the fuel in it. Maybe not the oxidizer, but certainly with the fuel. And there are zero hazards other than the kinetics of the rocket going down the road for folks. Questions for 5 or 10 minutes. I know we're preparing to call the FAA again as we narrow down upon the launch window.
Yeah, all right. Let's go to YouTube for comments here. Well, I don't think we have. Oh, here we go. So JJE40 asks, what should I do or learn to get an internship? We take all our interns through the Maine Space Grant Consortium, through their Aerospace Workforce Development Program. So that's who I would reach out to there. And then, Sasha, I don't know if you want to leapfrog off of that, but also they ask, how is the engine designed and what's the nozzle and casing made of?
Sure. So, with a hybrid rocket, the fuel, hybrid rockets can work multiple ways, but we have our fuel inside the casing, lined inside of our combustion chamber. Right now, we use, our engine has not been lightened for normal flight. It's quite literally the one we use as our test engine when we were working to optimize its performance and stability under a NASA grant. However, so the encasing itself is a metal casing, and the nozzle right now is a graphite nozzle that we're using currently. We have plans. Certainly the casing will change for Stardust 2.0, and the nozzle, we have some interesting changes for the nozzle as well that I can't get into yet.
Well, maybe we can have a big reveal next one.
Yeah, hopefully.
All right. So back to one of mine. Another pain point of a lot of folks that are trying to launch a CubeSat is they need to use a crew-rated launch vehicle, and so we're planning to sidestep that by just producing rockets that couldn't have a person in them anyhow.
Yeah, that's right. We, one thing that we learned when we interviewed about 40 customers and folks within our niche part of the industry, and what we learned from them is that they were really frustrated of launching their CubeSats and experiments to space because they had to make their experiments and CubeSats rated for land conditions, even though there wasn't an astronaut in the same rocket, because there could be someday. They had to meet the restrictions. That usually adds something like on the order of 30 or 40% more cost to the development time of those CubeSats. Again, since our rocket will be purely dedicated to launching non-manned or personed flight, and be very optimized, very much optimized to 1, 2, or 3 payloads in terms of trajectory and launch timing. We think we can get those costs way down for a lot of our customers. And a lot of our initial customers are going to be in the academic space, from academic and civil researchers. And we don't mean just academic and civil researchers that are in college or postgrad, but all the way down to elementary and high school students. In fact, every state has a space grant consortium that can receive funds to help them develop new science projects or fun science projects that they can launch in space with us maybe, or other companies here in the U.S. And NASA itself has additional funding to also support students and researchers from elementary school right through college years. And so our initial must is to focus on assisting students from any county, any town across Maine, but of course across the country, and ultimately across the globe, to do research in space, suborbitally and then orbitally.
Awesome. And so another interesting way that we're able to keep costs low, of course, is having a small team. I don't know how good this figure is, but I read that in America there's like 120 companies that are preparing to compete for this emerging small launch market. And most of those have significantly more employees than we do.
Sure. So that is, having been a part of the Alt-E team, a renewable energy company,
Oh yeah,
been
let's
around since 1999.
let's talk about that for a minute. Let's talk about how you're basically like the Elon Musk of New England.
I think that's an exaggeration, but
Okay, fine, the Tony Stark of New England.
right. I just need an attitude and a lot more money. One thing, when I started that up with Nick Albright and Jason Federspiel back in '99, we did that with blood and sweat equity, started from the ground up, and it was a lot of hard work, just like Blushift, but we did it organically and we grew it with its own funds and its own revenues to where it is today. And it's really successful today, once again, because we have a compact team, but also because we have really capable individuals on there. And that in many ways is very similar to Blushift. We have a core group of very capable people, and we are growing this organically, and we're planning to keep the team tight, because when you look at the marketplace for launching suborbital payloads to space or orbitally, you can see that the potential market in some cases is there's less value in 1 year than the cost of running a company with 100 or 200 people. So we're trying to keep our expenses low and our headcount not crazily high, besides the fact we can't afford it, but so that we can have a sustainable business into the future. Not one that's here for today or tomorrow, but one that keeps on running and running off of its own revenue profitably. And that's not easy to do in the space industry. You need a lot of money up front to do things like this launch. We will be going to the outside world to seek investment, develop our rogue.
And correct me if I'm wrong, but it is our goal in the next 5 years to create 40 aerospace jobs here in Maine.
That's correct. That's right. Yep. And I hope that whether or not we're successful here today, or if we end up launching and having to scrap a launch for another date, I hope that we serve as an example of what Mainers can do, and whether it's another company who starts up as a rocket company, or kids who are students today and want to start up a new satellite company, or want to develop a new software company for downloading data, to analyze data from space. I hope that we serve as inspiration to kids here in Maine, but anywhere that might be a rural state, and they might not think, well, we're not Florida, we're not Texas, we're not California, but we can do it too. And to have that go-gettedness and that sense of independence that you can kind of get from more rural states such as ours. And so I hope, if nothing else, we serve as an inspiration to other folks, and especially kids.
Yeah.
I think that I need to, my alert system is binging me, and it's telling me that I need to get back with the team here, so I'm going to have to hand over the microphone back to you, Seth.
Awesome.
But I'm happy to answer the questions post-launch, or if we scrub it, answer any final questions that people might have later on.
All right. Thanks, Sasha.
Thank you, Seth.
A busy guy, especially today. Always nice to chat. Well, if you have questions for Sasha specifically, maybe if you can note that in chat, and I'll try and take them down as they roll on by. Got a couple already here. Time Oakland asks, are we actively hiring? Not right now. You can send a resume to marketing@blueshiftaerospace.com. We'll keep it around. Mike Pafford asks about barge launching and the benefits of it. Well, barge launching is tricky, right? Because that's a whole new system that can have malfunctions when you're trying to get something as complex as launching a rocket done.
I wish I could have seen the face when it was active.
The advantages are mobility, being able to move that barge wherever you need to go to launch, so long as it's on the water. Can open up new launch windows that you might not have if you're just stuck on the ground. It helps with exclusion zones. Of course, a certain amount of area around the rocket, no one can be there for safety. And even in Maine, which is known for having a pretty low population density, it is really hard to find a place to launch a rocket. And so when we scale up and start launching to orbit, it may be simplest just because of the exclusion zone, just to get away from anybody for safety, to just head out to sea. There are some companies that launch from barges today. I think the main one is Copenhagen suborbitals. So we know that as long as you sufficiently stabilize that barge, which does become a challenge as the rocket gets bigger, but it is feasible. And then at some point, the rocket may be feasible to just launch from the water, like the old Sea Dragon concepts. Oh yeah, and one more thing about barge launching. Many launch sites, especially for orbital launch, are coastal. And the nice thing about a barge is as the sea level rises, the barge, of course, rises with it. So it may become not just convenient, but a necessity.
No, I'm just not.
Kathleen, Holly makes a good point about CO2 coming from the fuel. It is a combustion reaction going on there as the fuel and the oxidizer mix. So carbon dioxide is produced and released as the rocket, fires its engine. Now, one of the things that makes our fuel unique is that as you produce more of it, it absorbs much of that carbon dioxide back into it.
I mean, I'd be the same way. I'd be like, but they would just.
So it's a carbon neutral rocket fuel, which can greatly offset this rapidly growing industry of small satellite launch. Offset its carbon footprint. Sorry. Now, if you're just joining us, Welcome. It's a Blushift Aerospace live stream of the launch of Stardust 1.0. This is our prototype sounding rocket demonstrating our bio-derived fuel in flight
But it is cool because you
out
get to
of
see this.
Loring Commerce Center, the former Limestone Air Force Base.
And then
Sorry, Loring Air Force Base in Limestone,
in my
Maine.
memory, I remember like 5 minutes later hearing a little bit or something. I don't know if that's true. Yeah.
Indications are weather may improve at 2 to 3 p.m. Eastern. So we will evaluate at that point whether or not we can safely conduct a launch.
That would be really fun to watch.
All systems are go on the vehicle,
I would have loved to watch the shuttle land. And then land.
filling the oxidizer tank now and
Yeah.
holding for weather.
I mean,
Chicken Dick over suggests we should make some merchandise. We actually do have some merchandise through Spreadshirt. If you go to our website and click on the merch button, you'll get redirected. There's shirts and coffee mugs and a couple of phone cases, things like that.
Yeah.
as we wait here, might as well introduce you to the members of the team. So earlier, you get to hear words from Sasha Derry, founder and CEO. He founded a solar dealer, Alta East Store, in 1999. It's now a $24 million a year organization, and hired Real Goods, I think the first commercial retailer of solar panels in the U.S. Acquired them in 2019. Founded Blushift in 2014. Brooke Halverson, our lead test engineer, is responsible for working on performance testing logistics, manufacturing, and hybrid rocket motor assembly and testing. Luke Sandin, our senior mechanical engineer, assists with performance testing, oxidizer system design and evaluation, MATLAB code development and staging simulations. David Hayrikian, mechanical engineer. David Hayrikian, mechanical engineer, experienced in 5-axis CNC milling and founder of Maccabee Tech. He's responsible for CAD/CAM development of the hybrid rocket motor components, developing production processes. Our executive assistant is Bonnie Etheridge. Kind of keeps us all in line. Matt Parker, technical advisor. Led a test engineering team at SpaceX, where he helped develop, qualify, and produce the Merlin engines for the Falcon 9 launch vehicle. Oversaw development and operations of the Rutherford engine for Rocket Lab's Electron small sat launcher. And now manages the engineering team at Fiber Materials Incorporated to develop advanced composite materials for missile defense and space systems. And I am Seth Lockman, Communications Director, in charge of public, media, and government relations. I also handle Blushift Web, Blushift people you should know are interns funded by the Maine Space Grant Consortium's Maine Aerospace Workforce Development Program. James Giltner assisted with the layup of carbon fiber fuselage and main rocket casing, wired recovery, tether and quick disconnect arms, helped with on-site testing and rocket stacking. Ben Lemieux is a mechanical engineering major, wants to focus on rocket engines and aerospace engineering. And he was instrumental in rewiring our upgraded test stand when, under the NASA grant, we moved from an engine with a 4-inch diameter to a 6-inch. Kaylee Gallant helped model oxidizer behavior in the tank during flight. Contractors to thank: Gerard Desjardins, working on programming for the flight computer. Steve Savoy, composites expert, owns Savoy Composite Solutions, focuses on tooling design, process management, equipment evaluation and upgrades, workflow analysis and quality compliance. And at Blushift, Mr. Savoy manages design and manufacture of all composite components in the Stardust launch vehicle. Michael Ostermecki is a mechanical engineer and parachute rigger extraordinaire. If you're just joining us, this is Blushift Aerospace, a live stream of the Stardust 1.0 launch. This will be Maine's first commercial launch and the first commercial launch of a rocket powered by a bio-derived fuel. Right now, all systems are go on the rocket. We're holding for weather, hoping skies will clear as forecasted between 2 and 3 p.m. all the way up to our flight ceiling of 5,200 feet. The clouds do appear to be receding a little bit, but of course the final decision will be made based on weather reports. Eric Emery asks, are there plans for launches in Brunswick in the future? And the short answer is no, but we would never launch anything out of Brunswick. It's too densely populated. There's buildings, people, roads, that it just wouldn't do. Now you could control a mission from Brunswick, kind of like how. Just a second. All right.
Should we not bother filling that, or should we fill it?
I get my weather reports from rocket engineers, and what Mission Control is advising at this time is that the weather conditions are worsening. Cloud cover does not look like it's going to recede for 2 to 3. we can shoot for 3 to 4 just as a formality, because you always just keep trying. But barring a real surprise here, just leveling with everybody, it looks like the chances of a launch are not great right now. But that just means that we'll get to do this again next week. So, I believe I was answering the question, will we ever launch from Brunswick? And to make a long story short, no. For a rocket launch out of Brunswick, it just wouldn't work. You can't do that out of well, for Maine, it's a city. Now, with that said, it is possible that similar to what Virgin Orbit plans to do, or what Pegasus was, that launch system. Certain rockets can kind of be, slung under a 737, flown up to, above the densest part of the atmosphere, and then launched. And something like that could be done. Brunswick has, perfectly good runway at the executive airport. But for us, for rockets, vertical launch, if you will, Brunswick is not an option. It could be a good option for mission control, for data storage and processing, and business incubation, which is ongoing. Actually, we are one of 2 rocket companies in the state, headquartered at Tech Place at Brunswick Landing. Now, where would Blushift launch? Well, for suborbital, we'd love to see the spaceport develop the former Loring Air Force Base, and maybe get up here a little more often. For orbital launch to polar or sun-synchronous orbit, which isn't something, it's not the only thing we can do, but it's the market that we want to go after. To do that safely, we really need a coastal launch site, or if necessary, we could look at a barge launch or something like that. So that would be either in or based out of coastal down East Maine, somewhere in Washington County, probably. Elizabeth Kettner asks, what is a commercial launch? That is just a launch with paying customers, and Blushift Aerospace is well, it's not a government entity, right? It's a company or a private entity. And so when we launch something, it would be a commercial launch. Mike Pafford asks, what are the 3 logos on the rockets? Glad you asked. So in our current view, the top decal is the Blushift Aerospace logo. Let me see if I can make it a little bigger on the screen here. So that's what you're seeing, just much farther away. The middle one, that decal's something we're all very proud of. It says "Made in Maine." And then below the interstage at the top of the engine section of the rocket, that's the logo of Rocket Insights. They're one of our payload customers for this mission. Now in the chat, someone advised that I might be pronouncing this wrong, so apologies if that is the case. But Rocket Insights wanted to sponsor our launch. One of their partners had a personal connection with the state and thought it was really great what we were doing. And so they're sponsoring the launch, and they're flying a CubeSat with us. Their enclosure will contain a traditional Dutch wafer cookie called, and this is where I hope I'm pronouncing it properly, stroopwafels. Kind of an homage to their Amsterdam-based parent company. So those are the 3 decals from that angle. And from this angle, you see down at the bottom another Made in Maine decal. On the interstage, just a Stardust 1.0. Elizabeth McGovern asks, how heavy is the rocket? Unfueled, I believe it's about 540 pounds, and then fueled, it's close to 600. A couple questions about the timing of the launch. We're targeting 2 to 3 p.m. However, the outlook is poor. Weather forecast does not suggest that we'll have clear skies at that time. We're going to continue holding just because we can, and we can always hope that the weather will cooperate and improve. First trip. My God. It's been a minute. How are you doing? Asks if I can speak to career opportunities in the future at Blushift. So it is our stated goal to create 40 aerospace jobs here in Maine in the next 5 years. And we also support the initiative to create a spaceport here in Maine, which over its lifetime is estimated to create something like 75,000 jobs. We're not hiring right now, but depending on the results of this flight, we might be hiring very soon. You can reach out to express interest. Probably the simplest way to do that is just through the contact page on our website. But if you send a resume to the marketing at blushiftaerospace.com, I'll see it. David Stevens says, hopefully still edible after recovery, presumably in reference to the Stroop waffles. I like telling the engineers, don't toast the Stroop waffles. Space Gnome asks how much thrust the engine can generate. So the engine can burn at 2 Gs, which then, fighting the Earth's gravity, means it can accelerate straight up at 1 G. Oh, here's a good one. Reese Collins asks, what's the difference between polar orbit and the low Earth orbit? So the term low Earth orbit really speaks to how high the orbit is going to be. The term isn't formally defined, I don't think. But basically, from the moment that you can get to a stable orbit, which is a little bit above the Kármán line, out to a couple hundred miles is usually what we mean when we say low Earth orbit. Now, a polar orbit, that refers to the inclination of the orbit. So rather than its altitude, we're saying if you imagined a flat disk extending out from the Earth's equator, would your orbit be perfectly on that kind of a plane, what we call the ecliptic, or would it intersect with that plane? And assuming it's assuming that there is an inclination, then you can ask, what is that angle? And if the angle is 90 or negative 90, then you're going to pass over that planet's poles. So you can be in a polar orbit and a low Earth orbit. You can be in a polar orbit and a high Earth orbit. You cannot be in a polar orbit and a geosynchronous orbit. Quite welcome, Reese. Kynessel asks if we plan on going orbital, and the answer is yes. We plan to develop our presence in the suborbital market first, and then work on a 3-stage to orbit launch vehicle, which we're calling Red Dwarf. The plan is to focus on launching from a high latitude to a polar orbit, but it could reach other orbits as well. The beauty of our 30 kilogram payload capacity is that the CubeSat is the primary customer. There's no ride sharing. And so if they need to go to a weird orbit, all they need to do is find 2 or 3 other people that also want to go to that same orbit, and we can just do a custom mission. And even on the drawing board is launching a single CubeSat. Ooh, Riley Dunn mentions you could be in a polar geosynchronous orbit, but not polar and geostationary. Well, rest assured that I will be Googling that this evening and educating myself. I'll be using Google Scholar, don't worry. Mike Underwood asks, do cold temperatures affect launches? Good question. The biggest effect that the temperature has is on valves. Condensation around valves can turn into ice, and so we want to make sure that doesn't happen. Easiest way to control that is just heating. Rocket Guy asks, would you be using Alaska launch site for an orbital launch? That must be a reference to Kodiak. It's certainly an option. Yeah. If we can launch from Maine, though, we might not need to launch from an island. getting a rocket and all of its payloads to an island, it can be a little difficult. But what's really difficult is realizing that you forgot that one part back on the mainland. Oh, thank you for the clarification, Christian Bradley Hubbs writes, geosynchronous just means the orbital period is 24 hours. Geostationary is geosynchronous that hovers over the same point on the surface. Alright, well I just learned something rather publicly. Thanks, guys. Drew Goff asks, will you guys be developing reusable rockets? That is on the drawing board. Aiden Eisenberg asks if we're ever going to design or operate a orbital launch vehicle that carries more than 30 kilograms. Currently, we don't plan for that, but the engine is going to be fully modular, so in time, Starless Rogue and Red Dwarf will be more like standard templates, more like guidelines than models. And so if the Marvels can be configured in such a way that we could launch a larger payload and the mission called for it, I don't see why not. But we're dealing with hypotheticals that are years away. The reason for going with that 30 kilogram payload is, we touched on it earlier about CubeSats being the primary payload. And based on our research, that's where the demand is. MC Official Plays Space asks, will the rocket be landing intact? That is the plan. CB Manley asks how we keep the rocket stable for the first few seconds before thrust takes over. And that's a really good question. We've got that launch rail. The guide tower is about 72 feet long. A little longer than average. In part because Stardust 1.0 has a little bit of an irregular construction with steel in there. It adds weight to the overall structure, and so it just takes a little longer to get up to headway speed. Airbus 390 asks how many stages is Stardust 1.0? It's a single-stage rocket. However, on descent, it will split into the engine and payload sections, which will then remain tethered together as the rocket descends on parachute. So there is a separation, but there's only one stage. Well, Kendra Green asks, my science class is watching the live feed and would like to know what the rocket is fueled by. Well, that's just terrific. Hi, class. Study hard. So I can't say too much about what's in the fuel. It's our secret sauce. It's proprietary. I can say that it's a hybrid rocket engine, meaning that we have a liquid oxidizer and a solid fuel. Most rockets are either totally liquid, so you have liquid oxidizer, liquid fuel, or solid fuel, where you have the oxide and the fuel suspended in a kind of a gel-like substance. So we have a little bit of each. With the solid fuel, you can get some really terrific energy density, a lot of delta V, a lot of bang for your buck. And with liquid oxidizer, you have start-stop ability, throttle ability, and with only half of the systems being liquid, you save a lot on parts and plumbing, and there's fewer components that can malfunction, and you save weight and cost and all kinds of things. And then with the solid fuel, it's incredibly stable. It's got a 0 TNT value. So if hybrid rockets are so great, why don't we see them everywhere, right? And the answer there is because you're passing the oxidizer through or around the fuel core in the reaction chamber. As the fuel is consumed, as the rocket operates, the combustion chamber changes shape, right? And this is happening while the temperature and pressure are changing around the rocket. So it can be pretty difficult to sustain a stable reaction, especially at larger scales. And so that's one of the big technological hurdles that we had to overcome, in addition to inventing a new rocket fuel. If you're just joining us, this is Blushift Aerospace. We're doing a live stream of our launch of Stardust 1.0. This will be the first commercial launch in Maine, the first launch ever of a commercial rocket powered by a bio-derived fuel. Quick update on the weather. We were targeting 2 to 3. Now we're looking at 3 to 4. Odds of the weather improving at this point are pretty low. I did see a question in the chat from NASA asking when will we reschedule to if we have to scrub. The answer would be after the long weekend, after Martin Luther King Day. So potentially Tuesday or Wednesday. To launch, we need low winds, which we have actually. There's abnormally little wind for Limestone in the middle of the day, in the middle of the winter. Clouds are the main issue. The rocket's going to reach 5,200 feet above sea level, and we need less than 50% cloud coverage up to that height. At this point, cloud coverage pretty greatly exceeds 50% at and around apogee. Cloud ceiling appears to have lifted somewhat just based off of my own observation here. But it's not, well, cloud cover is not less than 50% all the way to 5,200 feet. If we do have to scrub today and are unable to launch due to weather or another issue, then yes, as soon as we determine a new launch date, we will make sure to let everybody know. It'll be all over our social. We'll schedule another live stream. We'll update the website, Eventbrite, Google Events, however you found out about us. We'll make sure to keep you posted that way. Well, thanks everybody for your understanding and support. It's definitely a little bit strange to work so hard on literal rocket science and then be looking at a scrub for clouds. All right, it looks like Sasha is about to do an interview with the press, so I'm going to duck the mic for a couple minutes while he does that. If you're just joining us, this is a Blushift Aerospace live stream of the
Well, thank you guys.
launch attempt, our first launch attempt for Stardust 1.0.
If it's ours, though.
So we've got kind of a tough announcement here.
We have one like it that we had the sanitizer.
We are
by the door
ceasing
going
launch
outside.
attempts for today.
I think that's it.
The launch is scrubbed due to weather. The cloud ceiling just will not cooperate.
Max.
So huge thanks to everybody who joined and stayed on the live stream,
All right. Tell Sandy. let
even
me
when we
know.
weren't
If
so
I
sure
tomorrow I can run up in the morning. I love
about the launch window. And there's been amazing comments and questions in the chat, and it's been really great to see all of you. And thanks to all the engineers and the volunteers who worked so hard to secure the field and coordinate traffic and everyone who put years and years of blood, sweat, and tears into this launch attempt. We'll try again, probably on Wednesday. We'll have a meeting, finalize that, and I'll make sure everyone gets updated wherever you are, however you find out about Blushift. It's definitely not the best feeling, but the rocket's fine. We'll just try again on Wednesday.
So there we have it. It looks like they are going to scrub for today, unfortunately, due to the weather. Rocket was good. Rocket was ready to go. Pad was clear. They were dealing with traffic and everything. FAA was ready. They had everything ready. Just the clouds didn't clear. And I think, as many have said in the chat and stuff, it's better to fly safe. As Elon has said many times, it's better to scrub than a RUD. You want, especially on your first flight, the results to be as best as possible. And I think that's what they're making the right decision rather than pushing and pushing and pushing. Also, you've got to look at time of year when the sun's going to set. They were already getting quite late into the day with between 2 to 3. So I think it was the right decision. It sounds like they are going to have some meetings and update us on Twitter later on. But they're going to take a pause over the weekend for the holiday down there. And sounds like maybe Tuesday, Wednesday, go at it again. So again, if you are new to the Launchpad, thanks for checking us out here at the Launchpad. We talk about everything space, space flight, space engineering, and the future of space. That's why we're covering today's launch. And we will be back here next time with Blushift. We will be back tonight with the launch of Rocket Lab. Hopefully we're going to see we've got Virgin Orbit coming up. We've got Starship in the next couple of weeks. Lots of exciting things coming up. Make sure to tune into our weekly news update every Monday night as we cover everything that's happened this week and everything to look forward to in the next week. But from here at the Launchpad, my name's Zach, signing off. Have a great night, everyone.